Welcome everyone and thank you for joining me today. I'm Dr. S. Kritika and in this session I'll be discussing about units and dimensions, which is an essential topic in engineering. In today's session we'll be discussing about basic concepts of units and dimensions, classification of physical quantities, systems of units, unit conversions and simple problems based on unit conversions. First, let us discuss about what are dimensions. Dimensions are the basic concepts of measurements and it is also a means of measurement of a physical quantity. What is a physical quantity? A physical quantity is any property of a material or system that can be measured and expressed in terms and numbers and units. For example, speed, force, energy, power, pressure and density. Units are the means of expressing the dimensions. Example, length can be expressed in feet, meter or centimeter. Time can be expressed in hour, minute or second. The units are very important and the units must be mentioned correctly. The misinterpretation of the units leads to problem. For example, NASA's Mars Climate Orbiter was a spacecraft designed to study Mars atmosphere. The spacecraft thruster calibration data was provided in pound seconds by engineering team at Lockheed Martin, but NASA's navigation team assumed the data was in Newton second. This led to the orbiter entering Mars atmosphere too low, causing it to burn up. So, from this we know that the importance of unit and dimension, it ensures accuracy in measurements. That is, by using standardized units, minimizes errors in measurement. For example, in medicine, a slight miscalculation in dosage, whether we are providing in milligram or gram, can have serious consequences and it avoids scientific communication. For example, a length reported in meter is universally understood by avoiding ambiguity from local units like feet or inches, and it provides consistency in engineering and industry. Mainly, the manufacturing and construction industry relies on measurements to ensure quality and safety. Physical quantities are classified into fundamentals or basics and derived quantities. The fundamentals and or basic quantities are the one which can be measured independently. The seven fundamental quantities are length, mass, time, temperature, amount of substance, electric current and luminous intensity. So the unit will be of single. For length, it's meter, mass, kg, like that fundamental, those units are called as fundamental quantities. And the derived quantities are the quantities which are developed in terms of fundamental quantities. For example, density, we can say it can be expressed by mass by volume, that is kg per meter cube. Velocity can be expressed as distance by time. And acceleration can be expressed by velocity by time. So all these are called as the derived quantities. And the systems of units. The proper handling of unit is an essential part of being an engineer. The system of units varies from country to country and some of the different system of units used worldwide are CGS, FPS, MKS and SI system. So in first CGS system, the length is expressed in centimeter, mass in grams, time in second and temperature in degrees Celsius. And in FPS system, feet, pounds, second and degree Fahrenheit. MKS system and SI system more or less has the same units like for length meter, mass kg, time second and for temperature Kelvin. Of all the systems used in worldwide, out of CGS, FPS, MKS and system, the most widely used and internationally used unit is the SI system. The SI system is the most widely used and internationally accepted one is the International System of Units or SI System of Units. It is used globally by ensuring uniformity in scientific and industrial applications. And SI system usually use multiples of 10, making conversion simple and convenient. And derived units are usually formed logically from base units. That is, for example, Newton can be expressed as kg meter per second square. So use of prefixes like milli, kilo, mega, deca to represent large or small values. So SI units reduces errors in measurements and communication. So all other SI units can be derived from base units. The table shows the 7 fundamental quantities, that is length, mass, time, temperature, electric current and luminous intensity and amount of substance with their standard SI units. For length, it's meter, mass, kilogram, time, second, temperature, Kelvin, electric current, ampere. For luminous intensity is candela, and for amount of substance, it is expressed as mole. And usually for representing a unit, there are some recommendations used. In the expression of a quantity, the unit symbol is always placed after the numerical value and a space is left between the numerical value and the unit symbol. For example, 10 is the numerical value and you should give a space and write down the unit kg. An exponent attached to the compound prefix unit implies that exponent refers to the entire compound unit and not just to the base symbol. For example, if it is 1 centimeter cube means the volume of a cube having 1 centimeter side. The product of two or more units may be indicated in any one of the following ways. Either Newton dot meter or Newton, leave a space and write meter. So you shouldn't combine and write the Newton meter. And then a solidus, usually a horizontal line or a negative powers may be used to express a derived unit formed from two others by division. For example, it can be written as meter per second or meter second inverse. A solidus must not be repeated on the same line unless ambiguity is avoided by parenthesis. That is, it can be represented as joule bar open parenthesis mole dot Kelvin. It shouldn't be like joule bar mole Kelvin. This is wrong and you should give a parenthesis in between mole and Kelvin. And always unit symbols do not change in the plural. 5 centimeters should be abbreviated as 5 cm and not as 5 cms. Unit symbols are not followed by a full stop except at the end of the sentence. And also prefix symbols are printed without any space between the prefix symbol and a unit symbol. So it should be written as 10.5 kilowatt, not as 10.5 kilo space watt. Compound prefixes formed by juxtaposition of two or more SI prefixes are not to be used. So you can write as 1 nanometer, but you shouldn't combine two prefixes like nano, micro together before prefix of the meter. And if the magnitude of the number is less than unity, the decimal sign should preferably be preceded by a zero. You shouldn't write 0.125. It should be written as 0.125. Next, we are going to discuss about the basic physical quantities, their definitions with their units. The first important physical quantity is the temperature. A temperature is a measure of cold or heat, or it can be defined as the degree of hotness of a body. The different units in which we can express temperature are degree Celsius, degree Fahrenheit, degree Rankine or Kelvin. The unit conversion between degree Celsius and Kelvin is that degree Kelvin is equal to degree Celsius plus 273.15. From Fahrenheit to degree Celsius, we can use the unit conversion as degree Celsius is equal to degree Fahrenheit minus 32 multiplied by 5 by 9. The next important quantity is the volume. Volume is the three-dimensional space occupied by a substance or enclosed by a substance on its surface. The different units of volume are meter cube, liter, or cubic centimeter. The unit conversion between meter cube and liter is 1 meter cube is equal to 1000 liter. Liter. The third physical quantity is the density. The density of the substance is usually expressed as mass per unit volume. The different units in which density is expressed are kg per meter cube or lb per feet cube or gram per centimeter cube. The SI unit of density is kg per meter cube. And next is the specific gravity. The specific gravity is the ratio of the density of the particular substance to that of the density of the standard. The density of the standard can be chosen as the density of water for liquids, and density of air can be chosen as the standard for finding out the density of gases. Density of water is expressed as 1000 kg per meter cube or 1 gram per centimeter cube. The density of air is 1.225 kg per meter cube or 1.225 into 10 raised to the power minus 3 gram per centimeter cube. The fifth physical quantity is the pressure. Pressure is defined as the force exerted on a unit area. Pressure is equal to force by area. The different units are Newton per meter square, or it can be expressed as Pascal, kg per centimeter square, or lbf per inch square, or it is also called as pound square inch. The other unit which we can express are bar or mm of Hg. So usually pressure is expressed as 1 atm. The 1 atm is equal to 101325 Newton per meter square or Pascal. The basic unit conversions used in pressure are 1 bar is equal to 10 raised to the power 5 Pascal, that is equal to 0.986 atm. Also 1 atm is equal to 760 mm of Hg or 1.01325 bar or 101325 Newton per meter square or Pascal. The next one is the force. Force is the push or a pull acting upon an object as a result of its interaction with another object. So mathematically it can be expressed as force is equal to mass into acceleration. The different units in which force is expressed are kg meter per second square or Newton or dyne. The unit conversion for all this is 1 Newton is equal to 1 kg meter per second square is equal to 10 raised to the power 5 dyne. Next is the work. Work is defined as the transfer of energy that occurs when a force is applied to an object, causing it to move in the direction of force. So work, the mathematical expression of work is force into displacement. The different units of work are joule, kilowatt, hour. The next one is the power. Power is defined as the rate at which work is done or energy is transferred per unit time. The unit of power is watt. Next is the heat. Heat is a form of energy that flows from higher temperature to lower temperature. The different units of heat are joule, kilocalorie, calorie, or British thermal unit, which is represented as BTU. Next one is the unit conversion and conversion factors. Usually, a unit conversion expresses the same property as a different unit of measurement. So distance, if you walk along a distance, the distance can be expressed in terms of miles, kilometers, feet. So you can convert the distance from miles to kilometers and kilometers to feet. So a conversion factor is a number used to change one set of units to another by multiplying or dividing. For example, 1 meter cube is equal to 1000 liter. So here 1000 is the conversion factor. The table shows some of the different conversion factors usually used in the unit conversions. So 1 kilometer is equal to 1000 meter, 1 kg is equal to 2.2046 lb, and we know that 1 ton is equal to 1000 kg, 1 liter is equal to 1000 ml, 1 atm is equal to 760 mm of Hg. So this is the chart showing us some of the basic unit conversion factors. So next we'll be doing some. So let us do some unit conversion problems. So first problem is convert 250 ml to liter. So usually for solving this unit conversion problems, we use the box model. So box model ensures that units cancel out properly and logically lead to desired final unit. It ensures a current arrangement of the numerators and denominators so that units cancel correctly and especially useful in multiple conversions. Let us go to the first problem, that is 250 ml to liter. So first we have to write down the conversion factor. 1 liter is equal to 1000 ml. Then write down the problem in the box model 250 ml. Denominator we don't have any numerals and units. So let us write down the unit. ml is there in the numerator. So same ml should come in the denominator so that the unit gets cancelled. So 1 liter is equal to 1000 ml. ml gets cancelled. So multiply the terms in the numerator and divide the terms in the denominator. So the numeral in the denominator is 250 divided by the numeral in the denominator is 1000. So you'll be getting 0.25 liter. So let us go to the second problem with two unit conversions. Convert 300 kg per meter cube to gram per centimeter cube. We should write down the unit conversions, that is 1 kg is equal to 1000 gram, 1 meter is equal to 100 centimeter. Let us write down the problem 300 kg per meter cube. So kg is there in the numerator. So in the unit conversion it has to be written in the denominator so that the unit gets cancelled. 1 kg is equal to 1000 grams so that kg gets cancelled. And meter is there in the denominator. For unit conversion the meter should come in the numerator. So we know that 1 meter is equal to 100 centimeter. Since it's cube, we are writing 1 meter cube is equal to 100 raised to the power of 3 and centimeter cube. Now the meter cube gets cancelled. So multiply the terms in the numerator, that is 300 into 1000, and divide the term in the denominator, that is 100 raised to the power 3. So the answer will be 0.3 gram per centimeter cube. So next we will solve the problem with So next we will go with 3 unit conversions. Convert 200 lb per feet square r to kg meter square per second. Let us write down all the conversion factors. That is 1 lb is equal to 0.4536 kg, 1 r is equal to 3600 second, and 1 feet is equal to 0.3048 meter. Let us write down the problem in the box model. 200 lb per r feet square. First let us do the unit conversion for the numerator. So we know 1 lb is equal to 0.4536 kg. So lb is there in the numerator. It has to be written in the denominator for unit conversion. Write down 1 lb is equal to 0.4536 kg so that lb gets cancelled. And next let us go to the denominator unit, that is r. R is there in the denominator, so it should be written in the numerator. 1 r is equal to 3600 second. So r gets cancelled. Next, between feet and meter, we know 1 feet is equal to 0.348. Since it's square, 1 feet square is equal to 0.3048 square meter square. So now feet square gets cancelled. Multiply the terms in the numerator and divide the numerals in the denominator. So you'll be getting 0.2713 kg per meter square second. So 200 lb per feet square r is equal to 0.273 kg per meter square second. Next is that you're going to prove that 1 BTU LB degree Fahrenheit is equal to kilocalorie per kg degree Celsius. For that, we have to write down all the unit conversions. So first, we don't know what is the direct conversion between BTU and kilocalorie, but we know that 1 joule is equal to 9.484 into 10 raised to the power minus 4 BTU, and 1 calorie is equal to 4.184 joule, and 1 kilocalorie is equal to 1000 calorie. And we know that 1 lb is equal to 0.4536 kg. And also delta 1.8 degree Fahrenheit is equal to delta 1 degree Celsius. So write down the unit in the box model, and first let us convert BTU to joule. And then after converting BTU to joule, convert joule to calorie, then calorie to kilocalorie. After that, convert LB to kg by writing 1 LB is equal to 0.4536 kg. Finally, for degree Fahrenheit to Celsius, so it is delta 1.8 degree Fahrenheit is equal to delta 1 degree Celsius, so that Fahrenheit gets cancelled. So when you multiply all the terms in the numerator and divide all the numerals in the denominator, you'll be getting the value as 1. So hence we have proved that 1 BTU per LB degree Fahrenheit is equal to 1 calorie per kg degree Celsius. So the next problem is convert 400 inch cube per day to centimeter cube per minute. Write down the unit conversions between inch cube and centimeter. 1 inch is equal to 2.54 centimeter, and 1 day is equal to 24 hour, and 1 hour is equal to 60 minutes. First, let us do the unit conversion for inch cube. We know 1 inch is equal to 2.54 centimeter. Since it's cube, write as 1 inch cube is equal to 2.54 cube centimeter cube. And write down for a day, since it is there in the denominator, for writing down the unit conversion, it should come in the numerator. So 1 day is equal to 24 hours and 1 hour is equal to 60 minutes. And day gets cancelled, hour gets cancelled, and multiply the terms in the numerator and divide the numerals in the denominator. That is 400 into 2.54 cube divided by 24 into 60 will give you 4.552 centimeter cube per minute. So last one is one more simple problem. We are going to convert 0.045 meter cube to ml. First, we need to write down the conversion factor between meter cube and ml. We know the unit conversion between meter cube and liter, and then we will write down the unit conversion between liter and ml. 1 meter cube is equal to 1000 liter, and also we know 1 liter is equal to 1000 ml. Write down the problem 0.045 meter cube. First, let us convert the meter cube to liter by writing down 1 meter cube is equal to 1000 liter. And then let us write between the unit conversion between liter and ml, that is 1 liter is equal to 1000 ml. So your answer will be 0.05 meter cube is equal to 45,000 ml. So in today's session, let us recap what we have done in the today's session. We have just discussed about the basic concepts of units and dimensions, and then what is a physical quantity, what are the different physical quantities, different types of physical quantities, and then what is unit conversion, importance of unit conversion, and simple problems in unit conversion. Thank you.